Yes, students, now I am going to start chapter number 5, Coordinate Geometry. This chapter is very simple, and for your first unit test, there will be two chapters, namely mensuration and this coordinate geometry. So, for this chapter, I have decided to give you the formulas as per the requirement of that exercise. Since we will be doing exercise 5.1 first, so for exercise 5.1, we simply have to use the distance formula. So please try to understand the distance formula. Distance formula is that supposing if I take 2 points A and B, A is having the coordinates as x1, y1, and B is having the coordinates as x2, y2. While finding out the distance between these 2 points A, of course, in xy plane, then distance formula is that distance A is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is how very easily you can find out the distance between these 2 points A. Now whenever you have to find out distance of any point from origin, in that case we can write the formula as distance, second formula, distance from origin. Distance from origin is equal to root of x square plus y square. This is a formula to get the distance from origin, because you all know the coordinates of origin are 0, 0. Now next questions based on this distance formula are: decide whether the given points are collinear or not. If 3 points are given, then you always find out the distance between 3 points, and later on you have to decide the sum of any two distances is equal to the distance between the third pair. Then in that case you can claim the given points are collinear. So this is how these formulas are there. These two formulas are only required to solve exercise 5.1. See here students, since I am going to solve all sums, I would like to request you, please copy down all these sums in your regular class notebook. As well as very soon, I will be giving you the test based on chapter number 7 of 40 marks, as well as test based on chapter number 5, that will be also of 40 marks. So let's start now exercise 5.1. Exercise 5.1 is there on page number 107. So please take out page number 107 and let's see how we are going to solve it. So in 5.1 they ask us to find out the distances between the pair of following points. So 5.1, first question 1, in that you will find out the distances. Find out distances. First point is given as A 2, 3, while point B is 4, 1. we have to find out distance AB. Now we will find, I will label the coordinates of point A as x1, y1. I will label the coordinates of point B as x2, y2. After labeling them as x1, y1 and x2, y2, now I am going to find out the distance between AB. So distance between AB is equal to root of x2 minus x1 the whole square, x2 minus x1 the whole square, plus y2 minus y1 whole square. So y2 minus y1 whole square. That will give me further square root of. Now let's substitute the values of x2, x1 as well as y2, y1. So you will find value of x2 is 4. Y cap of value of x1 is 2. So 4 minus 2 the whole square plus value of y2 is 1. So 1 minus 3 the whole square. That will give you square root of 4 minus 2 is 2. So 2 square plus 1 minus 3 is minus 2. You all know whenever we do the addition, in fact it is not subtraction, it's addition. So when I add minus 3 to plus 1, the sign of the greater number is minus. So that will go for answer. And 3 minus 1 is 2. Now next thing is, I'll get over here, 2 square is 4, as well as, since you all know, the square of minus 2 is also plus 4. So 4 plus 4 will get it as root 8. But you all know we can split 8 as 4 into 2. So that will give us 4 into 2. Square root of 4 is 2. So our answer is 2 root 2. So distance AB is equal to 2 root 2. So this is how, in a very simple manner, you can find out the distance between the given points. Now let's do the second sum. Now in second sum, the points are given as, the points are given P, Q. The coordinates of P are minus 5, 7, minus 5, 7, y cap of coordinates of Q are minus 1, comma 3. Same way as we have done in the first question. So label them as again x1, y1, y minus 1, 3 as x2, y2. Then we can say distance PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Here I have written formula first, then substituting the values. Root of x2, value of x2 is minus 1. x2 minus x1. Be careful now. I am going to write minus into minus 5. Please try to understand this very carefully. x2 minus x1. Value of x2 is minus 1. I have taken it as it is. Then minus, this minus sign also come over here. but you will find value of x1 is minus 5. I have placed it into the bracket. Next to that, y2 plus y2. Now y2 is 3 minus value of y1 is 7. The whole square. That is equal to minus 1 as it is, but minus into minus will become plus. So you will find here plus 5 the whole square plus, again you will find 7 is greater, so sign of 7 is minus. So minus 7 plus 3 is minus 4. That will give you 5 minus 1 is also 4 plus minus 4 the whole square. That will give us minus 4 square as plus 16. So next term is, you have to be very careful when second coordinate, especially either x1 or y1 is negative. That time you must have to place that into the bracket. So next step will be 4 square. So 4 square will give us plus 60 and minus 4 square is also 16. So next term is distance PQ is equal to 16 plus 16. So that will give us 16 plus 16 is 32. Now since I got 32, I would like to write this 32 as 16 twos are. So my next step will be 16 into 2, which is 32. Since you all know 16 is a perfect square. It is a perfect square of 4. So square root of 16 is 4. So final answer will be 4 root 2. So distance PQ is equal to 4 root 2. Is that clear? Now next is third one. Point R. Point R is having the coordinates as 0, minus 3. While coordinates of S are 0, 5 upon 2. Again you see R is having coordinates 0, minus 3, while S is having the coordinates 0, 5 by 2. So I'll call it as x1, y1. I'll call it as x2, y2. Now I am going to find out distance RS. So let's find out distance RS. Now distance R is also, we will find same formula. x2 minus x1 the whole square plus y2 minus y1 the whole square. Now let's substitute the values. Now for substituting the values, you will find value of x2. Value of x2 is 0. 0 minus value of x1. Value of x1 is also 0. The whole square plus, be careful dear students here, y2 minus y1, so 5 upon 2. But you will find y1 is having negative sign. So here also you have to be very careful. Minus of minus 3 the whole square. After substituting values, let's simplify. Here you will get it as 0 minus 0. The whole square will give you 0 only. But here in this case, 5 upon 2 plus minus into minus is plus. So it is 3 upon 1. whenever one is fraction, other one is an integer, for that integer we take the denominator as 1. So this is how I have taken it as 3 upon 1. Now I am going to simplify it, since you all know we call it as cross multiplication. So I am going to solve it by doing cross multiplication. So that will give us that is equal to distance, I think distance RS. So distance RS is equal to square root of. Now see here, dear students, how to do cross multiplication. 5 ones are 5 plus 3 twos are 6 upon taking the product of denominators. So 5 ones are 5 plus 6, 5 plus 6 upon, I'll get the product of 2 and 1 as 2 ones are 2. So this is how you can get the answer as 11 upon 2. In this case, dear students, we have to leave the answer here only. Why do we have to leave the answer here only? The reason being that 11 we cannot split it as the product of some perfect square number. In the same manner, you will find 2 also as it is, because 11 as well as 2, both of them are perfect square. So we have to leave answer like that only. Now let's proceed to the next question. That is fourth one. In the fourth one, coordinates of L are 5 comma minus 8, while that of coordinates of M are minus 3 comma minus 7 comma minus 3. Please take the coordinates 5 comma minus 8 and minus 7 minus 3. In this case also, I am going to label them as x1, y1, while the coordinates of n as x2, y2. In very simple way. So distance Ln is equal to same form, x2 minus x1 the whole square plus y2 minus y1 the whole square. All the time we are calculating the distance between the 2 points, and formula is same, x2 minus x1 the whole square plus y2 minus y1 the whole square. Now let us substitute the values of x2, y2 as well as x1, y1. The next step will give us Ln is equal to root of value of x2 is minus 7. So minus 7 minus x1, no problem at all, because you will find the sign of 5 is plus. So it's minus 7 minus 5 the whole square plus y2 minus y1. y2 is minus 3. Be careful now, because you will find the coordinate of y1 is minus 8. So I am going to write it as minus of minus 8. This is very important step to remember. Then that will give us, whenever both the numbers are negative, in that case we always add them and we write the addition of them. You all know minus 7 minus 5 will give us minus 12. The minus 12 the whole square plus the next step is important, because you will get here minus 3. But be careful here, I am going to give the effect of this minus sign on this minus 8. So minus into minus makes it plus. So that becomes now minus 3 plus 8 the whole square, minus 12 square, where it is plus or minus term, where squares are always positive. So you will get minus 12 square as 144 plus 8 minus 3 is 5, and square of 5 is 25. Sum of 144 plus 25 is 169, and 169 is a perfect square of 30. So if I take the square root of 169, I will get it as 30. So I write it as distance Ln is equal to 30. So this is how we can find the distances in very simple manner. Next to that is the question number 5. Now coordinates for question number 5. Coordinates for question number 5 are given as, please see into the textbook. Question number 5. T minus 36, T minus 3, comma 6, while the coordinates of R 9, comma minus 10, 9, comma minus 10. In the same manner, what I am going to do now, I will label them as x1, y1 and x2, y2. So the coordinates of T are labeled as x1, y1, while the coordinates of R I am going to label them as x2, y2. Same formula. Distance TR is equal to square root of x2 minus x1 the whole square. This is our distance formula. x2 minus x1 the whole square plus y2 minus y1 the whole square. Next step is that is equal to square root of. Our second step is substituting the values. So now you will find value of x2 is 9 minus value of x1 is minus 3. Again, I would like to tell you the same thing. Be careful here. Please place a bracket minus 3 the whole square plus y2 minus y1 the whole square. So value of y2, what is value of y2? Is minus 10. So minus 10 minus value of y1 is 6. So that will give you minus 10 minus 6 the whole square. The next step is 9. Now 9 as it is, but minus this minus into this minus will make it plus. So I'll get it as 12 plus 12 the whole square. Then minus 10 minus 6. If we add minus 10 minus 6 whenever there are similar sign possessed by both the numbers, we add and we put the common sign. So this is how you will get it as minus 16 the whole square. 12 square is 144, while the square of 16 is 256. So 144 plus 256 will give you square root of 400. But since you all know 400 itself is a perfect square, this is a square of 20. So we'll get this distance TR as 20. So this is how you obtain the value of distance TR as 20. So here you will find I finished fifth question of question number 1. Now there is one more question is there in question number 1. That is question number 6. In question number 6, you have to be a little bit careful because in calculations you will surely find fractions is also there. So in question number 6, W is equal to coordinates of W are minus 7 upon 2, while that of coordinates second is 4. Then you will find X coordinates are 11, 4. So I have written the coordinates of W as 7 minus 7 upon 2. Minus 7 upon 2, 4, while that of coordinates of X are 11, 4. Now let's find out distance Wx. So you will find that distance Wx is equal to, again you have to label them the coordinates of W as x1 divided and coordinates of x as x2, y2. So using distance formula, again you will find x2 minus x1 the whole square plus y2 minus y1 the whole square. The next step is simply to substitute the values of x2 y1 as well as x2 y2. So you will find that square root of value of x2 is 11, while that of value of x1 is minus 7 upon 2. Be careful here. Please place the value of x1 in the bracket, the whole square, plus y2 minus y1. But y2 is 4, and notice y1 is also 4. So 4 minus 4 the whole square. So that will give us 11 minus into minus. Okay, so minus into minus will give us plus. So 11 plus 7 upon 2 the whole square plus 4 minus 4 will get cancelled itself and will get 0. Now since 11 is integer, 7 upon 2 is a fraction, so I place denominator for 11 as 1. Now I am going to simplify it in very simple manner. The next step will give you this square 11 twos are. Now we are going to do so-called cross multiplication of 11 upon 1 plus 7 upon 2. So that will give you square root of. Please see here, dear children. 11 twos are 22 plus 7 ones are 7. So 22 plus 7 ones are 7 divided by product of the denominator. 2 ones are 2. Whole square. That will be 22 plus 7. 22 plus 7 is 29 upon 2. The whole square. Try to understand. I have done here 11 twos are 22 plus 7 ones are 7. 22 plus 7, I got it as 29 the whole square upon 2. Now you may do by this way that 29 square is 841 upon 4. 841 upon 4. So you will find that square root of 841 is 29 upon 2. So let's divide it. 2 ones are 2, 2 fours are 8, and 2 fives are 10. So this is how we will get the answer of this distance Wx is 14.5. You may think in this way, if instead of squaring this, if I would take the square root of this straight away as 29 upon 2, you are absolutely correct. In that case also, you would have got the same answer as 14.5. Now let's do question number 2. It is a very interesting question. Please decide whether these points are collinear or not. This is another type of question. So for solving this question, you have to find out the distances between the points. How will you find out the distances? You will find the distance between first 2 points, then you will find the distance between second and third, and then you will find first and last. Let's see the first question. I write heading here question 2, determine whether the points are collinear. Determine points are collinear. Okay, now let's see the first question. That coordinates of A are given as 1, minus 3. Coordinates of B are given as 2, minus 5. And coordinates of C are given as minus 4, 7. Okay. Now, in this case, what I will do? I will label them as x1, y1, x2, y2. And I label the coordinates of C as x3, y3. Okay? Try to understand. I have labeled them in a different manner. Now, I'll find out value of AB, I will find out value of distance BC, and also I will find out AC, and then I will verify whether the sum of the distances between any two is equal to the distance of the third one. Then I will conclude whether the points are collinear or not. So let's find out distance AB first. To get the distance AB, square root of x2 minus x1, the whole square, plus y2 minus y1, the whole square. That is equal to, as usual, I am going to substitute the values now. So value of x2 is 2. Value of x1 is 1. So 2 minus 1, the whole square, plus value of y2 is minus 5. And value of y1, you have to be careful, my dear students. Again, we got the value of y1 as minus 3. So what I have to do, I'll place bracket. That will give me 2 minus 1 is 1. So 1 square plus minus 5 minus into minus is plus. So minus 5 plus 3. Try to understand. Minus 5 plus 3 will give you minus 2. The whole square. You know this calculation is well. Now let's see the next step. The next step is, I will calculate this as 1 square. Very simple. 1 square is 1 only. 1 plus minus 2 square. Minus 2 square is plus 4. So I will get distance AB is equal to square root of 4 plus 1 is 5. Square root of 4 plus 1 is 5. Now I am going to find out the distance between points BC. So distance BC is equal to, now please see here students, our formula will change little bit, right? So I write this time x3 minus x to the whole square. x3 minus x to the whole square plus y3 minus y2 the whole square. x3 minus x2 the whole square plus y3 minus y2 whole square. Slight change because formula states that the coordinates of the second point minus the coordinates of first. But in this case, we are going to write the coordinates of third and 2. So naturally, coordinates of third minus the coordinates of second. So this way, x3. Now what is value of x3? Value of x3 in this case is minus 4. So I write it as minus 4. Value of x2 is 2 minus 4 minus 2 the whole square plus y3 minus y2. Now value of y3 is 7. Be careful again. 7 minus of value of y2 is also negative. So I will place a bracket and I will write it as 7 minus of minus 5. Bracket square. Now see here. You all know these simple calculations. Minus 4 minus 2 will give you minus 6. When we add both negative numbers, we add them and place a common sign. Next to that, 7 plus 5 the whole square, because you will notice minus into minus makes it plus. 7 plus 5 the whole square. I have already obtained the value of AB. Now I am going to find out the value of BC. So distance BC is equal to, the next step, distance BC is equal to square of minus 6 is 36. So plus 36 plus 7 plus 5 is 12, and 12 square is 144. So 36 plus 144, that is equal to distance BC is equal to square root of 6 plus 4 is 10, 3 plus 1 is 4 plus 4 is 8, 180, very important. 180. Now I have to think, is it possible for me to split 180 as a product of two numbers and one of them must be a perfect square? So let's simple way. Let's find out the factors. So if I find out the factors of 180, then I will get here 2 45s are 3 15s are 3 5s are and 5 ones are. If I will make a pair of these two similar numbers, then I will 2 3 3 2s are 6 root 5. So I will get the value very interestingly. Distance BC is equal to 3 2s are 6 root 5. Since you all know, I obtained the value of BC, I obtained the value of AB. Now what is left out? I am going to find out value of AC. Let's find out value of AC. Now we will know the A and C. C is a second point, very important. C is a second point, so I'll write it as, right? So I'll write it as coordinates of C first, okay? Minus 4, or I'll write it here first, x3 minus x1, the whole square, plus y3 minus 5n, the whole square. In this case, now I'll write it as value of x3 is minus 4. So minus 4. Value of x1 is 1. That is minus 1. The whole square. Plus y3. Value of y3 is 7. So 7 minus y1. Once again, we have to take care that placing bracket. So minus 3, the bracket square. That will give us minus 4 minus 1 is minus 5. So minus 5, the whole square, plus 7. Okay? Minus into minus is plus. So 7 plus 3 becomes plus 10, the whole square. So minus 5 square plus 10 square. Now let's calculate here the value of AC. Now I'm going to calculate value of AC. Value of AC will be, simple it is. So you will find that minus 5 square. Minus 5 square is 5 square is 25 plus you will find 10 square is 100. So 100 plus 25, distance AC is equal to 125. This number 125, you can write it as 25 paisa. So distance AC is equal to 5 into 25. Why I have written this number 125 as 5 to 25? Very simple reason. Because 25 is a perfect square. And you can take the square root of 25 as 5. So you'll get it as 5 into 5. So distance AC is 5 into 5. Distance AB is only root 5. And we will find distance BC is equal to, what distance BC? That is equal to 6 root 5. Now from these three quantities, you can surely verify what you can notice over here. That distance of BC is equal to distance of AC plus distance of AB, correct? Because 5 root 5 plus root 5 is equal to 6 root 5. So we can write it as we have to give explanation of course, that distance BC is equal to distance AC plus distance AB. Distance BC is 6 root 5. While that of distance AC is equal to 5 root 5. And distance AB is simply root 5. Okay? So we can write it as 6 root 5 is equal to 6 root 5. Therefore, points B, A, C, because BA plus AC is equal to BC, or you can say points B, A, C are collinear. So this way, my dear students, we have solved the first question of 5.1, as well as I have also solved this first question of question number 2 of 5.1 to decide whether the points are given collinear or not. So here I finished the first lecture of this chapter number 5. Overall, it may be my 9th or 10th lecture. I will announce it at the next lecture. Thank you. I am going to request all of you, please see that, please copy all these sums in your regular notebook of school. Thank you.